Veolia was awarded the contract to design and build a waste-to-energy scheme for Arla's facilities management company, NG Bailey. The drivers for the plant were to meet three key requirements. Firstly, to treat the wash water from the milk processing operations and to return the clean water back to the sewer. But before the clean water can be returned, it must adhere to the required discharge specification set by the local water authority, Thames Water. Secondly, to generate biogas from the Memthane process to generate energy for milk processing in the dairy. And finally, Arla's key objective was to consider its impact on the environment and showcase its sustainable development target of becoming a zero-carbon facility, whilst, at the same time, reducing its carbon footprint and reusing resources and energy across the process. Drawing on Veolia's global process technology portfolio and expertise in bespoke engineering and design capabilities, Veolia was able to design and build a wastewater solution. In order to meet the requirements and objectives set out by Arla, Veolia designed, supplied and commissioned the waste-to-energy facility in two specific phases. Veolia installed a Memthane wastewater treatment solution for anaerobic stage as part of phase 1 of the project, and following a step change in milk production, increased the plant capability to treat increased hydraulic flows and organic loads, adding Anita-Mox and DAF technologies for aerobic stages as part of phase 2 of the project. Memthane is an anaerobic bioreactor, also known as ANMBR, and it maximises the renewable energy production whilst producing superb quality effluent which can be discharged directly to sewer within stringent regulated consent limits. Developed by Biothane, a Veolia company, this patented cutting-edge technology delivers a number of benefits, most noticeably reducing discharge costs and generating valuable biogas and fertiliser. Wastewater that is generated in the milk production process is cleaned using the anaerobic process, giving clean water. The byproducts of the process are biogas for energy to be used in the dairy and biomass produced in the reactor that, once thickened, is harvested and used as a substitute for land fertiliser for farmers. Phase 1 was designed to treat 500 cubic metres per day of wastewater and 5.5 tonnes of COD, meaning chemical oxygen demand, which is a measurement of organic pollution in the wastewater. The process stages of the system include a balance tank, Memthane anaerobic reactor, ultrafiltration membrane banks, and flash aeration before clean water is discharged to sewer. Any gas generated through this process is supplied to a combined heat and power system to recover electricity or used to supply the heat energy in the milk production process. After a year of Phase 1 operation, Phase 2 was designed and built to provide resilience and robustness in the wastewater treatment process, which will ensure that even in the event of a reactor failure, water treatment can continue. Reactor 1 runs continuously, and Reactor 2 is maintained intermittently to ensure resilience and milk production continuity. The Phase 2 design upgraded the plant to treat 800 metre cubes per day of wastewater and 8.7 tonnes of COD, and added aerobic stages of Anita-Mox and dissolved air flotation at the end of the process chain to reduce the levels of ammonia and phosphate in the sewer discharge. Veolia has optimised the treatment of the wastewater from the dairy process, contributing to the sustainability of the dairy. Built a robust solution that can operate over a wide range of variations in volumes and strengths of wastewater produced, giving Arla the capability to develop and bring into production new products at the Aylesbury site. The inbuilt flexibility of Veolia's wastewater treatment process has ensured a continued reliable operation. the Memthane process has returned greater than 99% of COD reduction in the wastewater. Biogas yield has been between 0.6 to 0.7 normal cubic metres per kilogram of COD reduced, converting the energy to be reused in the dairy or returned to the national grid. Disposal routes of other byproducts have also had a positive environmental impact and used as land-spread non-chemical fertiliser for crop production by local farmers. Contact us for more information at www.veoliawatertechnologies.co.uk.